A dye is a colored substance that has an affinity to the substrate to which it is being applied. The dye is generally applied in an aqueous solution, and may require a mordant to improve the fastness of the dye on the fiber. Both dyes and pigments are colored because they absorb some wavelengths of light more than others. In contrast to dyes, pigments are insoluble and have no affinity for the substrate. Some dyes can be precipitated with an inert salt to produce a lake pigment, and based on the salt used they could be aluminum lake, calcium lake or barium lake pigments. Natural. The majority of natural dyes are from plant sources: roots, berries, bark, leaves, and wood, fungi, and lichens. Textile dyeing dates back to the Neolithic period. Throughout history, people have dyed their textiles using common, locally available materials. Scarce dyestuffs that produced brilliant and permanent colors such as the natural invertebrate dyes Tyrian purple and crimson kermes were highly prized luxury items in the ancient and medieval world. Plant-based dyes such as woad, indigo, saffron, and madder were raised commercially and were important trade goods in the economies of Asia and Europe. Across Asia and Africa, patterned fabrics were produced using resist dyeing techniques to control the absorption of color in piece-dyed cloth. Dyes from the New World such as cochineal and logwood were brought to Europe by the Spanish treasure fleets, and the dyestuffs of Europe were carried by colonists to America. Dyed flax fibers have been found in the Republic of Georgia in a prehistoric cave dated to 36,000 BP. Archaeological evidence shows that, particularly in India and Phoenicia, dyeing has been widely carried out for over 5,000 years. The dyes were obtained from animal, vegetable or mineral origin, with none to very little processing. By far the greatest source of dyes has been from the plant kingdom, notably roots, berries, bark, leaves and wood, but only a few have ever been used on a commercial scale. The discovery of man-made synthetic dyes late in the 19th century ended the large-scale market for natural dyes. Synthetic dyes are man-made. These dyes are made from synthetic resources such as petroleum byproducts and earth minerals. The first human-made organic aniline dye, mordant, was discovered serendipitously by William Henry Perkin in 1856, the result of a failed attempt at the total synthesis of quinine. Other aniline dyes followed, such as fuchsin, safranine, and inulin. Many thousands of synthetic dyes have since been prepared. Types of dyes are classified according to the solubility and chemical properties. Acid dyes are water-soluble anionic dyes that are applied to fibers such as silk, wool, nylon and modified acrylic fibers using neutral to acid dye baths. Attachment to the fiber is attributed, at least partly, to salt formation between anionic groups in the dyes and cationic groups in the fiber. Acid dyes are not substantive to cellulosic fibers. Most synthetic food colors fall in this category. Basic dyes are water-soluble cationic dyes that are mainly applied to acrylic fibers but find some use for wool and silk. Usually acetic acid is added to the dye bath to help the uptake of the dye onto the fiber. Basic dyes are also used in the coloration of paper. Direct or substantive dyeing is normally carried out in a neutral or slightly alkaline dye bath at a near boiling point, with the addition of either sodium chloride or sodium sulfate or sodium carbonate. Direct dyes are used on cotton, paper, leather, wool, silk and nylon. They are also used as pH indicators and as biological stains. Mordant dyes require a mordant which improves the fastness of the dye against water, light and perspiration. The choice of mordant is very important as different mordants can change the final color significantly. Most natural dyes are mordant dyes, and there is therefore a large literature base describing dyeing techniques. The most important mordant dyes are the synthetic mordant dyes, or chrome dyes, used for wool. These comprise some 30% of dyes used for wool, and are especially useful for black and navy shades. The mordant, potassium dichromate, is applied as an after-treatment. It is important to note that many mordants, particularly those in the heavy metal category, can be hazardous to health, and extreme care must be taken in using them. VAT dyes are essentially insoluble in water and incapable of dyeing fibers directly. However, reduction in alkaline liquid produces the water-soluble alkali metal salt of the dye, which, in this leucoform, has an affinity for the textile fiber. Subsequent oxidation reforms the original insoluble dye. The color of denim is due to indigo, the original VAT dye. Reactive dyes utilize a chromophore attached to a substituent that is capable of directly reacting with the fiber substrate. The covalent bonds that attach reactive dye to natural fibers make them among the most permanent of dyes. Cold reactive dyes, such as Precion MX, Cibacron F, and Drimrine K, are very easy to use because the dye can be applied at room temperature. Reactive dyes are by far the best choice for dyeing cotton and other cellulose fibers at home or in the art studio. Dispersed dyes were originally developed for the dyeing of cellulose acetate, and are water-insoluble. The dyes are finely ground in the presence of a dispersing agent and sold as a paste, or spray-dried and sold as a powder. The main use is to dye polyester, but they can also be used to dye nylon, cellulose triacetate, and acrylic fibers. In some cases, a dyeing temperature of 130 degrees Celsius is required, and a pressurized dye bath is used. The very fine particle size gives a large surface area that aids dissolution to allow uptake by the fiber. The dyeing rate can be significantly influenced by the choice of dispersing agent used during the grinding. Azoic dyeing is a technique in which an insoluble azo dye is produced directly onto or within the fiber. This is achieved by treating a fiber with both diazoic and coupling components. With suitable adjustment of dye bath conditions, the two components react to produce the required insoluble azo dye. This technique of dyeing is unique in that the final color is controlled by the choice of the diazoic and coupling components. This method of dyeing cotton is declining in importance due to the toxic nature of the chemicals used. Sulfur dyes are inexpensive dyes used to dye cotton with dark colors. Dyeing is affected by heating the fabric in a solution of an organic compound, typically a nitrophenol derivative, and sulfide or polysulfide. The organic compound reacts with the sulfide source to form dark colors that adhere to the fabric. Sulfur Black 1, the largest selling dye by volume, does not have a well-defined chemical structure. Food dyes. One other class that describes the role of dyes, rather than the mode of use, is the food dye. Because food dyes are classed as food additives, they are manufactured to a higher standard than some industrial dyes. Food dyes can be direct, mordant and VAT dyes, and the use is strictly controlled by legislation. Many are azo dyes, although anthraquinone and triphenylmethane compounds are used for colors such as green and blue. Some naturally occurring dyes are also used. Other important dyes. A number of other classes have also been established, including oxidation bases, for mainly hair and fur, laser dyes, rhodamine 6G and coumarin dyes, leather dyes, for leather, fluorescent brighteners, for textile fibers and paper, solvent dyes, for wood staining and producing colored lacquers, solvent inks, coloring oils, waxes, contrast dyes, injected for magnetic resonance imaging, are essentially the same as clothing dye, except they are coupled to an agent that has strong paramagnetic properties. Mayhem's dye, used in water cooling for looks, are often rebranded applied.The. Chemical classification. By the nature of the chromophore, dyes are divided into category acridine dyes, derivates of acridine; category anthraquinone dyes, derivates of anthraquinone; aryl methane dyes; category diaryl methane dyes, based on diphenylmethane; category triaryl methane dyes, derivates of triphenylmethane; category azo dyes, based on N=N azo structure; diazonium dyes, based on diazonium salts; nitro dyes, based on ANO2 nitro functional group; nitroso dyes, based on AN=O nitroso functional group; phthalocyanine dyes, derivatives of phthalocyanine; quinonamine dyes, derivatives of quinone; category azan dyes, category urodan dyes; category safranon dyes, derivates of safranon; indamines; category indophenol dyes, derivates of indophenol; category oxyzone dyes, derivates of oxyzone; oxyzone dyes, derivates of oxyzone; category thiazine dyes, derivatives of thiazine; category thiazole dyes, derivatives of thiazole; category safranon dyes, derivates of safranon; xanthine dyes, derived from xanthine; fluorine dyes, derivatives of fluorine; pyronon dyes, category fluorone dyes, based on fluorone; category rhodamine dyes, derivatives of rhodamine.